The European Space Agency's Galileo mission has now entered a new phase. With Galileo, ESA and the European Union are building and deploying the world's first civilian-owned and operated satellite navigation system. It will make Europe completely independent in this key domain. In 2011 and 2012, the first 4 satellites of the constellation were launched into orbit, allowing the project to go through one of its most crucial phases, the so-called in-orbit validation, or IOV.
The IOV phase in the Galileo program was required to demonstrate that the future performance that we want to meet when the full system is deployed are effectively reachable. So it was an intermediate step with a reduced part of the system to effectively give the evidence that we were on track with our expectations.
With the 4 satellites in orbit, ESA has created a mini-constellation. Galileo is not only based in space, but it includes several elements on Earth, like a number of ground stations. These are required to receive the satellite signals and send timing messages to the satellites. Satellites and stations are managed by 2 different control centers. One is located at Oberpfaffenhofen in Germany. It's in charge of the control segment, meaning it's primarily responsible for flying the satellites. The other is located at Fucino in Italy.
The ground control center in Fucino is responsible for operating the mission segment of Galileo. In this phase, therefore, we generate the navigation message. It is distributed to the ground of network stations and uplinked to the satellites. From the satellite, it is then again downlinked both to user terminals and to a network of stations which are receiving the signal and feeding it back into this center.
The in-orbit validation was started with the first Galileo-only position fix. This happened on the 12th of March 2013 in the Navigation Lab in Noordwijk in the Netherlands. A historic day for Europe. But in order to ensure the system's capability, it was also mandatory to check these signals outside a laboratory environment. And so ESA went on to test the system in the field. Receiver equipment was embarked on a laboratory van, which drove thousands of kilometers to get position fixes all across Europe. Several other means of transport have also been tested in recent months.
We have been also performing flight trials in cooperation with Eurocontrol. We have been flying airplane over the Netherlands, embarking on this airplane test receivers that have shown good results. And end of last year also we have started to perform the first maritime test with receivers embarked on a boat in the North Sea.
Galileo has clearly demonstrated it's on the cutting edge of technology, flying the most advanced timing equipment, hydrogen maser clocks, and giving accurate timing performances up to a few nanoseconds, with positioning on the ground down to a few meters.
Europe has proven with the IOV that in terms of performance, we are at par with the best international systems of navigation today present in the world. I mean the US GPS and the Russian GLONASS. In terms of performances, we are really extremely good and fully comparable with those systems. So we demonstrate to Europe that we can do what Europe has done in all space fields until now, and we demonstrate to the world that we are now a partner and a credible partner.
Now that Galileo has successfully completed its in-orbit validation phase, a huge step has been taken by the European Space Agency towards the full deployment of the Galileo system, soon ready to provide its first real services.